So let's give it up for Team 2B, led by Victor Tang, with their facial blurring in videos to protect privacy project. And make way over there. Yeah. Our presenters today are Victor and Paul. Actually, the whole team will be presenting today. So, judges, let's get it started, guys.
All right, you all hear me well? All right, cool. Hey, what's up, guys? I'm Paul.
I'm Victor. You already heard that, but
cool. So our project today was really focusing on real-time obscuration of faces to protect people from privacy and whatnot. So privacy is a big issue nowadays. You take videos, I take pictures. You're taking my picture right now, and some people might want to be in that picture, some people might not. And so it's important to be able to distinguish who should be in that picture and who should not. And blurring faces nowadays is one way to protect identity. Issue with that is it can be time intensive and mistakes can happen. As you can see over here, we have an image of someone's face blurred on the top screen, and on the bottom screen her face is now suddenly unblurred because someone made a mistake. And this is a process that can be easily automated, as you can see from Google Street View, where they can easily detect faces and automate that. So we decided to apply that same technology to video feeds to detect and track faces and blur them.
okay. So I want to go over the technology that we used. We programmed it in Python. We used OpenCV as our computer vision library. We used dlib to help keep track of all of our faces, and we used a method called HAR cascades as a way of detecting faces. And now we're going to move on to a little demo.
Yeah, so we used our web cameras from our computers to be able to blur our faces, and that's how it looks in practice, and we can move around. And so this is a real-time video, like it is just my web camera, and our faces are blurred, as you can see. And we couldn't decide which type of blurring is better, so we actually made two types. So you see the first one already, and let me show you the second one. So here it is, and this is like a smoother version, and our faces are blurred again. So it works on multiple faces. Yeah.
Yeah, and this could take multiple video. This could not only use for your webcam, but also you can feed it video inputs in different formats to do the blurring.
Also, what we focused on is to track the face. So once the face is detected, it's being tracked. So if we twist our face a little bit, some algorithms had a problem with detecting it at that time, but we fixed it by tracking the face.
So as far as where we would take this into this program in the future, we would add selective blurring, where you would be able to choose which faces to blur and what parts of the face to blur. We would have better data for our recognition models so that it would be much more accurate at detecting faces. And we would improve the accessibility, where it would be a much more easy way where anyone without any kind of experience in this would be able to use it effectively. So thank you all for listening. Are there any questions?
All right, we're going to have 2 minutes for questions, starting now from the judges, if you have it.
So where do you see this technology most likely to be applied? What companies be interested in it?
I see that, really foresee this kind of technology being applied to companies that are still using more hand-based censorship. That's probably the best place to start, because that's man hours right there, and you can be saving quickly. Even if it's not perfect, it's still a great start.
So if it's not perfect, what happens if there's that one frame where you may not lose tracking? Is there that risk that someday people will capture that and all this work is for naught?
So that's definitely something that we've encountered a lot. And so in the initial stages, it would be used for videos where you would apply it once and most of the blurring would be done immediately, and then you could go in and hand blur some of the other where it messed up. And in the future, we'd be able to train our models better to be a lot more accurate at detecting faces.
How did you decide which technologies to use to implement this?
So past personal experiences, I happen to have had personal experience with OpenCV already and happen to be aware of the models that already exist. So it's quick for us to think, what do we know, what are we good at, and just put them together in order to quickly slap something together that works to demonstrate to y'all.
So is one of these technologies new to the scene that you haven't used before?
DLib is something that personally I have not used. It happens to be a little bit better.
None of us did.
Yeah, none of us have heard of it prior to today. So.
Also, the model that we used that is trained for face detection, that's also new to all of us.
All right, thank you guys. So our next team is going to be team group name. So thank you. Please give a round of applause for team 2B. Judges, you will have 3 minutes to complete your grading criteria, and